polynomial and rational functions. Polynomial and rational functions. Polynomial functions, the first and the simplest and the easiest polynomial function is linear. We refuse to go back to it. We're done with it. Done. We graphed it. We know everything about it. Slopes, everything. We reviewed that. The next in line is quadratic. Yes, we did a lot about it, but I'm going to start from scratch again. And any polynomial, degree 3, 4, 5, 6, and so on and so forth. And when we're done with that, we're going to look at rational functions. I feel a sneeze coming on. Sorry. My apologies.
That's a problem. Poly in the degrees, like if it's to the third degree, the fourth degree, or so on.
We had equations with degree 3 and 4. We didn't really have degree 5 and 6. So polynomial functions, linear, the simplest one, quadratic is the next level, and polynomials of degree higher than 2, 3, 4, 5, 6. Okay, so let's go back to quadratic functions. And this is section 3.1. Especially graphing and word problems. That's what I would like to look at. So section 3.1, quadratic functions. Quadratic functions. We can be given quadratic functions in two different formats. They mean the same thing. Ax squared plus bx plus c. That's one type. And here's another type, x minus h squared plus k. And no, h and k do not mean, it happens we use the same letters, but it's not the center of a circle. But it happens that we use h and k again. Okay, so for now, forget about this. I'll explain this in a minute, but let's look at that one. And let's look at an example. F of x, negative x squared minus 4x minus 3. Obviously, the leading coefficient is a equals negative 1. A is negative 1. B is negative 4, and C is negative 3. And the question here is graph this function f of x, negative x squared minus 4x minus 3. We have to go through several steps, and I will mention that on the test and the final. Step number 1, yes, domain. Can anyone give us the domain of this function, or any polynomial function for that matter? All the numbers, no restrictions whatsoever. We know that. Perfect. Negative infinity to infinity. Number 2 is the shape. Now we know how this will look like. Will it look like a circle? No, because that's not a function. It will look like a parabola. So there are two options. Either the parabola opens upward, as we know, or it opens downward. Very good. Awesome. Exactly. So this point is called vertex, and so is this point called vertex. But this one specifically, it's a minimum, but of course this one is a maximum. If the leading coefficient is a positive number, the parabola will open upward. How do we know? Remember x squared. We graphed that square so many times. It had a positive leading coefficient, so it's opening upward, right? Good. Here, the parabola will open downward. It will have a maximum when the leading coefficient is negative. So the shape for our situation, in this example that we just picked, what will it be? Oh, yes. Yes, perfect. So it will have a maximum. Excellent. Number 3, the vertex. So we want to determine this point. This is a key point, either max or a min, in this case, a max. This is a key point. So the question is, how do I find it? Say it again. No.
Would you just lazy me? I would graph it and then find it on my calculator, but I assume that's not how we're supposed to do it.
Nice try. That's good. Okay, let's talk about the quadratic formula. We all remember negative b plus or minus the square root of b squared minus 4ac over 2a, right?
Yes.
So
Yes, please, Mana.
it wouldn't be just, it wouldn't be 0, negative 1.
No.
It wouldn't be that.
No. Okay, so we all remember this, right? The vertex is a point, right? It will have an x coordinate and it will have a y coordinate, correct?
Mm-hmm.
Good. So the question is, how do I determine the x coordinate? Here's how I determine the x coordinate. The reason why I put the quadratic formula up there is because I like you to connect it. Here is the x coordinate of the vertex. That's it.
Negative b over 4.
Exactly. So maybe because I used so much whiteout, you will remember this. So the x coordinate is negative b over 2a. And we need to remember this anyway, so why not connect them? Okay, now the question is, how do I find the y coordinate? Say it again.
You mess with what's I don't know.
Let's suppose I get that this is 5. How do I determine the y coordinate? Say it again.
Would it be C?
Say it again.
Would it be C?
You have to graph it on the thing and look for it.
No, this is a crucial idea.
What do you put 5?
Of course, it's f of that point. Thank you, Brianna. Thank you. So it's f of negative b over 2a. This is a crucial idea. So we do have to remember this. If I'm given a function, and if x is 20,000 or 200 or whatever, I have to plug it in to find the y value. Awesome. Good. As long as we remember moving forward, I'm fine.
Way harder than that.
Correct. Good. So let's find negative b over 2a. So how much is negative b over 2a? Negative stays in the formula. B, how much is b?
Negative 4.
Good. How much is 2 times a?
Negative 2.
I see 3 negatives. The answer will be
Negative.
-2. Very good. So now I have that the vertex has -2 as the x coordinate. Again, how do I find the y coordinate? Excellent. Excellent. Thank you. So I have negative outside. Be very careful. Put enough parentheses when you need them. -4 times -2 and -3. We have to square first. -2 squared
Is 4.
with minus in front.
Minus 1.
Very good. -4 times -2
Plus 8.
and -3. This is -7 plus 8 is
1.
perfect. So we found the coordinates of the vertex. We're moving on to step 4. X-intercept, comma, if they exist. Oops, what does that mean?
Sometimes it doesn't pass the X.
Awesome, that's exactly it. One more time, does this function have a max or a min?
Oh, I have a max.
Excellent. There are three possibilities for a maximum. Let's analyze all three, please. So here's one possibility for a maximum. Here's a second possibility for a maximum. And here is a third possibility for a maximum. How many X-intercepts do we have here? One, and that's also the vertex. Would you agree? One real solution, which is the vertex as well. How many solutions here?
Two.
Two real, distinct. Here they're not distinct, they're the same. Two solutions, right? The same. Distinct, two real distinct solutions. How many solutions here? No real solutions.
And if our vertex is -2, 1, then it would be the last case, right?
So -2, 1.
Oh, so it was up.
So is it case 1, case 2, or case 3? Say it again? Yes,
Would be the middle one.
it will be the middle one because the vertex is -2, 1, which means the highest y value is not 0, is not negative. It doesn't stay below the x-axis, but it's a positive number. So it must be this case. So I want to come back to the quadratic formula. Yes?
I don't know how, because the first one says it's equal to vertex. So how is that it's...
Because this is also the maximum. So the x-intercept and the maximum are the same point.
Because if only one dot touches it, it has to be the maximum. If you have two, then it can be two random things. It doesn't have to be the...
Is that better? So is it clear why this is the case here?
So that's not a coordinate, that's -2 and then a 1.
These are the coordinates of the vertex, yes. And it will look like this. This is not the exact graph, but it will look like this because the maximum is 1 and the range will be from -infinity to 1. It's not, the range will not be from -infinity to 0, and it will not be from -infinity to -3.
If it was -2, 0, would it be the first one?
-2, 0, it would have been the first one. Yes. Better, everyone? Okay, so now I would like to go back for 1 minute, back to the quadratic formula. There is something that in equations I did not mention because I wanted to mention it now. We didn't use it before. Now we're using it. So over 2a. Okay. Now look at the quadratic formula, and since there is only one solution, what should this quantity be? This quantity is extremely important. It's called discriminant, and it's b squared minus 4ac without the square root. Just this quantity under the square root. It's called discriminant. It's also called delta, but we don't need that. So now here's the question for you. If there is only one solution, well, it's a double solution, but we say one solution. What should the discriminant be in this case? How much should b squared minus 4ac be here? How much should be in this case? B squared minus 4ac, and how much should be in this case? B squared minus 4ac. If there is only one solution, obviously this must be 0. There is no plus or minus. What about here? Since we get two solutions, what kind of number should b squared minus 4ac be? Because I can take the square root from it, right? So it must be very good. And when I cannot take the square root and I don't have real solutions, exactly. Exactly. So discriminant is 0. Say it again.
I'm sorry, you can ask this question about this, as far as the, what you just did.
The discriminant?
Yeah.
Yes.
Okay.
Yes. So the discriminant is 0 when there is only one solution, one real solution. The discriminant must be positive when there are two distinct solutions. And the discriminant must be negative when there are no solutions. We cannot take the square root from a negative number. That's why there are no solutions. That's why the function does not cross the x-axis. So, coming back to the title of number 4, x-intercepts, if they exist, will they for this function?
Yes,
Of course.
there's two.
I don't want to waste my time. Because with these two, I will be wasting my time. With this one, I will be wasting my time because I didn't notice that it's the same with the vertex. With this one, we will be wasting my time because I will use the quadratic formula, spend the time, and how many solutions will I find?
Two.
None.
No,
That's okay. I know you didn't look. Yes. Right? So if it's this, I'm done right away. If it's this, I'll say no solutions. But for this one, I have to work. Ready? How do I find the x-intercepts? I know they exist. How do I find them?
plug 0 for y.
Exactly. Y equals 0. Awesome. So we had negative x squared minus 4x minus 3 equals 0. And we know the keywords in this class or any math class. Factor, simplify, no negative leading coefficient, and descending order.
We could factor that.
Yes, but no, not before I multiply both sides by negative 1. So this is x squared plus 4x plus 3 equals 0. And yes, I will factor.
It's going to be x plus 2 and x plus 1. Or 3, sorry. Because 3 plus 1 is 4.
Good. So then x equals and x equals.
Negative 1 is just
Very good. And what are the ordered pairs that we just determined?
negative 1, 0, negative 3, 0.
Excellent. This is number 4 now. No, I'm lying. This is number 5, right?
Yes.
Number 5. What do you think number 5 would be?
Y.
Of course. When I determine the y-intercept, this will always exist.
This is x-intercept, right? Sorry. I messed up.
So this will always exist. So how do I find the y-intercept for any function?
Put 0 after x.
Exactly. So I find f of 0. Can anyone give us f of 0?
Negative 3.
Perfect. Can anyone give us the ordered pair that is the y-intercept?
0.
Very good. 6 and 7 are just words, but very important words. 6. X equals, what was the vertex? 2 comma negative 2. Yes.
Why is it negative 3? Not like we use negative 3 by negative 1.
When you stick 0, it's the only.
0, 0, I cannot just change that into negative 1.
Oh my goodness.
Better? Good. So the vertex was negative 2 comma 1. X equals negative 2, axis of symmetry. We are not talking about odd and even functions here. You'll see in a moment how we graph it. So what is, in this case, a max or a min? One more time. Max. Max value of f of x is how much?
Whatever the y coordinate is.
Perfect. Negative 1. It was negative 2 comma 1. Positive 1. Very good. And last one, 8. We haven't even graphed the function, but we know exactly how it looks like. I would like you to write it or give us the range. What is the range of this function? Imagine the graph.
If it can't go above 1, it would have to be
Negative infinity.
1.
Excellent. That's it. Let's graph, finally.
I now understand why you asked for range last and not first, or like after.
Because we had to go through all the steps exactly. First, we have to graph the vertex. -2, 1. The next step. Now notice this is not using transformations. Everything here is accurate and exact with points and everything, right? Good. So then we draw the axis of symmetry, which is not a solid line. It's not part of the graph, but it has to be graphed.
Hold on a sec. What did you just write first? Is the first one that you read?
-2, 1, the vertex.
What is this negative x equals -2?
That's the
Axis of symmetry. The vertical line through the vertex. X equals -2. Everyone else? Any questions? Okay, then we go back. We have -1, 0, and -3, 0. Notice something very important. These 2 points, the X-intercepts, must be symmetric. This one is 1 unit away to the right. This one is 1 unit away to the left. They have to be symmetric with respect to the X equals -2. And finally, we have Y equals -3 as the Y-intercept, sorry. So then, try to make it as symmetric as possible and not too acute at the vertex. This is the graph of x squared negative x squared minus 4x minus 3. And we have absolutely no secrets. We know everything about this function. Any questions?
yeah, I did.
Go ahead, please.
Now you just graphed the symmetric, the vertex. What else did you graph on there?
I asked the vertex, first the vertex, then the axis of symmetry, then the X-intercept.